Hey, welcome back. This is 1.4 day 1. So the first question, number 1, is can the average rate of change of a function be constant? Well, yes. If I have a value, let's say I had the function y is equal to 7. So it's just a constant function that always has a height of 7. Well then, from 1 to 2, if you ask how it changes, at 1 it's 7, and at 2 it's 7. So the change would be 0. Well, how would we know that? We would take f at 2 minus f at 1 over 2 minus 1, which is just our change in y over our change in x. And that's going to be 7 minus 7, because the output is always 7, over 2 minus 1. So we get 0 over 1, which is 0. Number 3, how are absolute and local extrema different? Local is saying that you're either the biggest or the smallest only on a small interval, a small open interval. And absolute mins or maxes are over the entire graph. More importantly, over the whole domain for all inputs. So if I went bloop, 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 so here at A is, because I can get a small open interval around it where it's the biggest one, A would be a local maximum. But over here at this value, since this is the highest value we ever see over the entire domain, then this would be the absolute maximum. It's absolutely the biggest. Question number 5. So it asked us to find the average rate of change. So we're going to find the change in f over the change in y. And it wants us to find, for the function f of x is equal to 4x squared minus 7, it wants us to find the average rate of change on the interval from 1 to b. So if I'm going from 1 to b, well then my x1 is going to be 1, and my x2 is going to be b. So I'm going to say f at my x2 minus f at my x1 over x2 minus x1, because that's the equation we have memorized. But guess what? x2 is just b, and x1 is just 1. So now when I look at this, what I see is f at b is the output you get out of the function when you plug in b. So maybe over here on my scratch work, f of b is 4b squared minus 7. F of 1 is just the output you get when you plug in 1, so that's simply negative 3. But notice, it's a chunk of stuff, all of f of b, minus a chunk of stuff, all of f at negative 1. So this negative times this negative gives us a positive. These parentheses are really, really important. Then negative 7 plus 3 is a negative 4. So now I have a fraction. So you're really done at this point. But if I ask you to simplify, you must continue on further. So you should be happy. Give yourself a high five if you got this far. Now let's see if you can simplify. I've got a fraction. I factor the top by factoring out a 4. But then I notice that this can be broken up with a difference of two perfect squares, b minus 1 and b plus 1. Those b minus 1s cancel out, and I get this as my average rate of change, 4 times b plus 1. I put myself a little note, b can't be equal to 1, because I canceled out this factor. Then I look at number 11. So when you are looking at number 11, the function is a of t is equal to 1 over t plus 4, and I want to know, how does this function change from 9 to 9 plus h? So what does that mean? That means I'm going to find the change in a over the change in t, which means I'm going to be able to find a of 9 plus h. I'll make sure that that's clear, that that's a 9, that this is an a, and this is an a, and this is a 9. So then I'm going to find a at 9. And I'm going to subtract those and divide by 9 plus h, my second point, minus 9, my first point. So here is 9 plus h, correct? And so 9 plus h just means you plug in A of 9 plus h just means you plug in 9 plus h into the function 1 over stuff plus 4. Well, then the 9 and the 4 give you a 13, and so anytime you see this, you can replace it with this. So I'll replace this with what it's equal to. And then A of 9 just means you plug in 9 into A, and we get 1 over 13. So again, trying to make my A's and my 9's look different. So that would be what this is. Then in the denominator, if you have 9 plus an h, subtract a 9, the 9's cancel out and just leave you with h. If you get this far, good job on you. Give yourself a high five. That is as far as you need to go for this second. By the end of the semester, I would love it if we can simplify this interesting thing. And the reason I do it is because later on you'll find out that this sort of a difference quotient, where you have a subtraction and a division, this sort of a difference quotient will be important for a little bit of calculus, okay? Just a little bit. It's not like we're going to be doing difference quotients every day. And so let's see if we can't simplify this. Well, the first thing I'm going to say, if you have stuff divided by h, that's the same as multiplying all that stuff by 1 over h. So dividing by h is the same as multiplying by 1 over h. Well, then you have 1 over 13 plus h minus 1 over 13. And since those are two different denominators, I must multiply to get the common denominator. And this object is what we call a well-chosen one. It is a good choice. We actually have two different well-chosen ones. When you do that, you end up getting 13 times 1 is 13. And the bottom ends up being 13 times 13 plus h, and we need our parentheses. But then make sure here it's this times 1 gives us all this, but make sure we have these parentheses on the top. Okay, so now when you see this, we have a negative that we can now distribute in. The negative hits 13 and makes it negative 13. The negative hits the h and makes it negative h. Why is that beautiful? Because the 13s now cancel out and just give us negative h on top. And why is that beautiful? Because we have an h on top and an h on bottom. Because they're multiplied by the top and the bottom, they can cancel out, and we come up with this final answer. Getting to here is all you would have to do on a test that we have. This is what we will work the entire year trying to get better at. So look at it now. If you can do it, good on you. If not, we have time. Okay, so that was 11. We now go on to 15. So if we look at number 15, so 15, again, wants you to find the average rate of change. It said f at x plus h minus f at x over h for the function f of x is equal to 2x squared minus 3x. Well, we're just going to have a chunk of stuff minus a chunk of stuff over h. Well, notice we already know what f of x is. So I can just put in 2x squared minus 3x for f of x. But I have to go and figure out what does it mean to be f of x plus h. Well, that simply means you take your f function, which is 2 stuff squared minus 3 stuff, and everywhere where you have a stuff, you plug in x plus h. Okay, so let's simplify that a little bit. I guess we take x plus h and square it. If you'll allow me to bring this down here. Let me bring it down here. And you're going to have an x plus h times an x plus h minus 3x plus h. So in here you're going to get x squared plus 2xh plus h squared. Right? Here I'm going to distribute through this 3 to get negative 3x minus 3h. And then over here I'm going to distribute through this 2 to hit everybody. I'm going to get 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Yes, that's ugly. No, you will not have to do that very often. So now inside of here, I can just put all that. 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Because all of this is another way of saying, all of this is another way of saying f of x plus h, right? Okay, so now we distribute through a negative, so that's really negative 2x squared. Distribute the negative in this is plus 3x. Well, why would that make me happy? Because over here, notice what we had. We already had a 3x, so this and this cancel out. We already had a 2x squared, so that and that cancel out. So really what I have is 4xh plus 2h squared minus 3h, 1, 2, 3, all over h, right? But then, is there anything common to the entire top? Yes. We can pull out an h, and you're left with 4x plus 2h minus 3. And you'll see these h's cancel out, and you're simply left with, I can erase that, you're simply left with 4x plus 2h minus 3. And that is your difference quotient. You'll notice as h goes to 0, we get 4x minus 3, which is something we will do in a later course, but there you go. Again, if you got, I think we would make that look pretty. Yeah, I think that that's definitely one that you can probably do. It's kind of ugly because there's a lot of algebra. So if you stop here, that's a lot of credit, right? But I think this one, with a little bit of work, we should be able to do. It would definitely be one of the more difficult ones on an exam because you have to be careful with the algebra, but I hope it is doable. So that's 15. Now I look at what comes after 15. 17 and 19. So if I look at 17 and 19, I'm going to take a picture. I'm going to crop it. So let me just do this. So 17 and 19. I'm going to say done, save to photos. So on yours, here, paste. So 17 wants to know the average rate of change from x equals 2. So I look at 2. Oh, I could say average rate of change on the interval from 2 to 5. Well, average rate of change is going to be f at 5 minus f at 2 over 5 minus 2. I would write all this down so I slow myself down and make fewer mistakes. Well, what is f at 5? I go up to 5. It looks like f of 5 is 7 minus f at 2 just looks like it's 3. Over 5 minus 2, we're going to get 4 over 3 is the average rate of change. And that is number 17. After that is number 19, which of course is another graph. So I go back to the book for you. Look at 19. That's going to be 19. Take a picture like so. I'm going to say done, save. Go back to my other app. Take a picture, put it in. So there's 19. So what's going on with 19? They want us to tell increasing and decreasing intervals. So it looks like as my inputs go from negative infinity up to about here, that's increasing, right? The graph seems like as we walk from left to right, it's rising. So increasing would be negative infinity to about negative 2.5. And it looks like it's increasing again from 1 out this way. From 1 out to positive infinity. Note all of these are open intervals. They do not include the endpoints. Then for decreasing, it looks like the graph is decreasing here down to here is the only point, or the only interval, excuse me. So that's going to be from negative 2.5 to 1. Notice how when we look at these, we should end up getting the entire number line because the graph on this one is either all increasing or all decreasing. Cool. 19, right? Was that 19? Yep, it says down there. And so now I need 21. So now I look at number 21, which looks like this. And I go here and here. And I say done, save. And then I go and give me a new page and plop it right in there for you. Blammo. So let's talk about increasing. It looks like, for what inputs is this increasing? Looks like it's increasing from negative infinity all the way up to 1. So negative infinity to 1. And then it looks like it's increasing here. So I guess it's right after 3 all the way up to 4. So from 3 to 4. Now we really see why we don't include the endpoints, because there's a vertical asymptote here, right? Vertical asymptote. And then it looks like if we're talking about decreasing, this thing is decreasing here. So that's from 1 all the way up to 3. And then from 4 to infinity. All right, that was 21. Let's now look at 22. So 22. Oh, I said 22. Man, there's a lot of these. I don't know if I necessarily need to give these many next time. They want both 22 and 23 is what I asked for. 22 and 23. So I'm going to say done, boom. 22 and 23. Let me go picture, paste. 22, 23. So for 22, it wants to know increase, decrease. I think you can see by now that increasing is going to be from negative infinity to 3, and then from 3 to infinity, and it looks like it's going to decrease in here. It's going to decrease from negative 3 to 3. That's a really pretty function, by the way. Estimate the points where it has a local max or min. Looks like this thing is going to have a local maximum at y is equal to whatever this is. So that's about 55, something like that, at y is equal to, looks like it might be at about 3. And for a minimum, it looks pretty symmetric, so I'm going to say y is equal to negative 55 at y is equal to 3. Oh, this one over here should have been negative 3. So this is at y is equal to negative 3. Oh my gosh, why did I say y? I'm not redoing this video, it's x, sorry. You know what I meant. So, the way we always say it is, if you want a maximum, it's at this output, happens at this input, and I have a minimum of this at this input. But clearly mark which one is the minimum and which one is the maximum. So after 23, I need 24 and 25. So 24 and 25, we're so almost done. I go kablamo, kablamo, 24, 25. I say done, save, and then I come over here. Oh, poop. 24, what's up?
Hi.
I'm almost done with this video. 24 and 25. It says estimate the intervals of increase, decrease. I think it's pretty clear that increasing goes from, it looks like it's going to be here. Notice it stops. So that's going to be from negative 8, we don't include, all the way up to negative 3. And then it increases from, oh, is that negative 8? Is that, let me see what that is. That might be closer to 7, actually. So So this is going to be negative 7. If you guys can hold it down just for a minute, that would be great. I'm just finishing up this video. And then this is going to be from 3 to 7. Thank you. And then decreasing is going to be from negative 3 to 3. Right? Notice I stopped because I had the dots. And then it says absolute min and absolute max. The absolute minimum, it looks like you get an absolute minimum of y is equal to negative 225, and it occurs at x is equal to negative 7. It looks like you have an absolute maximum of y is equal to 150 at x is equal to 7. And that's it. Have a great day. Bye.